Hi friends, welcome to Basics of Computer. In this session, we will understand hexadecimal number system in detail. We will learn how to convert a given decimal number to a hexadecimal number system and back from hexadecimal number into decimal system. The number system we have learned till now, binary and octal, although are important from concepts point of view, it is this hexadecimal number system which we use very frequently when we are working with computer in day-to-day life. So please pay attention to this system. First, let us understand basics of hexadecimal number system. Hexadecimal number system is a base 16 number system. So the number system is called hexadecimal. Base is 16. Going by our formula, the valid digits of a hexadecimal number system is 16 minus 1. Base is 16. So 16 minus 1. So valid digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. But it goes up to 15. 10, 11, 12, 13, 14, 15. But the problem is we are saying it is a valid digit is going up to 15. But starting from 10, we are already having 2 digits. Then what is the meaning of saying it is a single valid digit which is 10, 11, 12, 13, 14, 15? In hexadecimal system, to solve this problem, up to 0 to 9, there is no issue. We have a single digit. But for writing number 10, we start using letters. We use A to represent number 10. Similarly, we use B to represent 11. And we use C to represent 12, D for 13, E for 14, and F for 15. Now with this, notice in a single digit's place, we can write, say for example, if I write A in one single digit, it means it is 10. Similarly, in a single digit, if I write F, it means it is 15. So now we are able to write 0 to 9 and 10 to 15 in hexadecimal number. What is important is 10 is represented by A, 11 by B, 12 by C, 13 is D, 14 is E, and 15 is F. So after we reach F, we go back to 0 again. So each digit can have values between 0 to F, F standing for 15. There are a lot of places where we may even see small letter A, B, C, D. Both are meaning the same. Sometimes people write capital A, B, C, D, or sometimes people write small letter A, B, C, D, E, F. Both mean the same basically. A representing 10, B representing 11, and so on and so forth. Let us understand the place value of this using base to the power n approach. So base in this case is 16. So first place value is 16 to the power 0. Second is 16 to the power 1. Third is 16 to the power 2. 16 to the power 3. 16 to the power 4. And it goes on like this. So 16 to the power 0, if we solve, actual place value will be 1. The next place value is 16 appearing 1. So it is 16. Next place value is 16 into 16. It comes to 256. Next place value 16 into 16 into 16 or 256 into 16. It comes to 4096. Similarly, next is 16 to the power 4. 16 multiplied 4 times or 4096 multiplied by 16. We get 65536. So these are the place values in hexadecimal number system. So just to understand, if there is a number 0005 with 16 written at the bottom, it means it is a hexadecimal number system. How do I expand this? Take the first digit, which is 5, into place value 1. Second digit into place value 16. This time the second place value is 16 because of hexadecimal number. Third is 0 into 256. Third place value 256. Fourth place value 4096. So if we solve this, 5 ones are 5, plus 0, plus 0, plus 0. If we add this, we get 5 to the base 10. We'll take one more example. There can be a hexadecimal number having any of these letters. Look at this example. We have 002A. So this is a hexadecimal number, valid hexadecimal number, because A is a valid digit in hexadecimal number. So 002A to the base 16. If we expand this, first, what is the value of A? A corresponds to number 10. So my first digit is A into 1 or 10 into 1. Place value is 1. 10 because A represents 10. Next is digit 2. 2 into place value 16. 0 into 256, 0 into 4096, nothing. Notice A to F are valid digits in hexadecimal number system. Whenever we get A, we have to put the value 10. If we happen to get, say, D, we have to take value 30. So in our case, we have A as a first digit, so we took 10. 10 into 1. So if you solve this, 10 ones are 10, plus here place value 16, we have digit is 2. So 16 twos are 32, plus 0, plus 0. Now if we add this, 32 plus 10, we will get 42 to the base 10. So 002A to the base 16 is 42 to the base 10. Take a look at this and try to get a basic understanding of hexadecimal number system. What is important? Valid digits are 16 minus 1, base is 16, so 16 minus 1. So it goes up to 15 after 9, 9, 10, 11, 12, 13, 14, 15. But these numbers, 10, to rewrite it in a single digit, using a single digit, we make use of A. 10 we write as A, 11 we write as B, 12 we write as C, 13 as D, 14 as E, 15 as F. So after we reach F, again it comes back to 0, because F is the last digit. 15 is the last digit. Take a look at it and understand. Let's continue and try to understand exactly how to convert a given decimal number to a corresponding hexadecimal number. We know the process. Let us repeat, but this time for hexadecimal base 16. Now to make it more easier, we ensure we write down here so that we can easily map the letters to corresponding value. Let's take a simple example, 8 to the base 10. Number 8 in decimal, we want to convert to 16. Start dividing 8 by 16. 8 is already less than 16. So 16 zeros are 0, remainder is 8. And we write the answer bottom to top. We know the drill. So 8 to the base 10 is 08 to the base 16. Very simple example, no much complication. Let's take one more example. This time we'll take 58, 58 to the base 10. Start dividing 58 by 16. How much can we go up to? 16 threes are 48, and hence 16 threes is 48. So 58 minus 48 is remainder 10. So we got 16 threes are 48 and the remainder 10. Can we continue to divide 3 further? No, we stop here. And we have to write the answer from bottom to top like this. But here we have an important step. The step is 3 we can write as it is, but how do we write 10? 10 has to be written as A, because in hexadecimal A stands for 10. So what we write here is 58 to the base 10 is 3A to the base 16. Notice when the remainder was to be written as 10, we wrote it as A, because this is the correct digit to be used. So 58 to the base 10 is 3A to the base 16. Let's take one more example. This time 76 to the base 10. Try to divide. 16 fours are, we get 64. So 76 minus 64, the remainder is 12. 4 can we continue to divide? No. Let us stop here. And we have to write the answer in this order. But an important step here in hexadecimal number is, what is the exact digit for writing 12? Letter C. So 12 has to be written as C. So when we write the answer, 76 to the base 10 is 4. Then next is C to the base 16. So 76 to the base 10 is 4C to the base 16. Take a moment to see and understand. The important point is, it is possible that either the quotient or remainder can be anywhere between 0 and 15, but wherever we get numbers from 10, 11, 12, 13, 14, 15, we have to write the corresponding letter as a digit. Like in this case, instead of 12, we wrote C. That is how we should write the answers. Let us solve some exercises. Take 223 and try to convert it into a hexadecimal number. We have to start dividing by 16. Ensure to write the remainders, and while writing the answer, make sure wherever we get numbers between 10 to 15, we write the corresponding letters. Give it a try. Let us try to solve. We want to divide 223 by 16. Let us do this with a classical division method. 223 divided by 16. So first two digits is 22. So 16 ones are 16. So if we 22 minus 16, if we do, we get 6 here. Get the next digit 3 down, 63. 16 fours will be 64. So we have to go only up to 16 threes. 16 threes 48 is what we get. And if I subtract, what I'm going to get is 3 minus 8 I can't do. So I take 13 minus 8. So I get 5. And here, because we had borrowed a number, this was 5 minus 4. We get 1. We stop here. We cannot continue. We know that quotient is 13. Remainder is 15. Stop at this point. Now notice. So write 13 here. Quotient here. And there is a remainder 15. Write the remainder here. Note, quotient we are writing here, remainder we are writing here. Can we continue to divide 13 further? No, 13 is smaller than 16. We'll stop and write the answer from bottom to top like this. But important point is, we got 13. So 13 we have to write as D, and 15 here we have to write as F. So the answer for us would be 223 to the base 10 is df to the base 16. What we did? We started dividing 223 in the classical method of division till we got a proper quotient and remainder. Quotient we write here and the remainder we write at the remainders place. And when we stop at appropriate places, make sure we write the corresponding letter to represent the numbers. 13 as D, 15 as F. Take a moment to understand what we did. We'll try to solve one more problem. 430 to the base 10. Try to solve this. Like we did in the last example, you can do a classical division method to arrive at the quotient and remainder. That will make the process simple. Let us see. So we want to convert 430 to base 16. Start dividing by 16. Let us do a classic division. 430 divided by 16. 16 twos are 32. So 16 twos are 32. Subtract 3 minus 2 is 1 and 4 minus 3 is 1. Bring the 0 down. Next what? 16 6s are 96. Right? So now if we subtract 0 minus 6, we cannot do, borrow a number. So 10 minus 6, we get 4. And this was 0, so it's again 10. 10 minus 9 is 1. So can we divide 14 further? No. What we got is quotient is 26. We write quotient here. And we got remainder 14. We write the 14 here. Next thing here is, can we divide 26 further? Yes, 26 is bigger than 16. We can continue to divide 26 further. Let us do it. Do the classical division method. 26 divided by 16. 16 ones are 16. 6 minus 6 is 0. 2 minus 1 is 1. So 10. So what we got? Quotient is 1. Remainder is 10. This quotient we write here. The remainder 10 we write here. Can we divide further? No. And we stop. Now we have to write the answer from bottom to top like this. Digit 1 we can write as it is. For 10 it is bigger than the 9. We need to write the corresponding letter, which is A. Similarly, for 14 we have to write E. So our answer would be 430 to the base 10 is 1AE to the base 16. Notice 1AE to the base 16. A representing 10, E representing 14. Cross check. Did you get the same answer? This is how we do the conversion between decimal and hexadecimal. Now we'll see how to do the opposite conversion. Hexadecimal back to decimal. In this, whatever numbers we used for converting between decimal to hexadecimal, we will use the same to convert back from hexadecimal to decimal. This will help us, one, understand how to convert hexadecimal to decimal, and we can also cross-check whatever answers we got earlier are correct or not. But for doing this, let us make sure we remember the valid digits of hexadecimal number, which is 0 to 15, and we have also written down letters as digits for representing 10 to 15, which is A, B, C, D, E, F. This helps us in converting our numbers. Let us see how. We will also write down the place values using the base 16, following the base to the power n pattern. And this is the values we have for each place. Let's take our first example. 0008 to the base 16. Notice it is base 16. So first digit is 8. Place value is 1. Next is 0. Place value this time is 16. Notice we are this time converting a hexadecimal number to a corresponding decimal number. So take 8 into place value 1, 0 into place value 16, 0 into 256, 0 into 4096, nothing in front. If we solve this, 8 ones are 8, 16 zeros are 0, plus 0, plus 0. So if we solve this, 0008 to the base 16 is 8 to the base 10. Simple. It is almost same. But the complication happens when we get a bigger number. Say for example, 3a to the base 16, 0038 to the base 16. Now when I am expanding this, a represents 10. So my first digit a, which is 10, should be multiplied by 1. A should be replaced with 10 multiplied by the place value, which is 1. Next digit is 3. 3 into place value 16 this time. 0, 0. And if you solve this, 10 ones are 10. 16 threes are 48. So if you solve this, we get 48. Plus 0, plus 0. So if we add this number, 48 plus 10, we get 58 to the base 10. Notice, whenever we got this letter A, we take the corresponding number we have here. Like for A, we took 10. Similarly, if there was C, for example, we should take 12. This can happen in any of the places. We'll take one more example. 4C to the base 16. So the first digit is C. So C stands for 12. So in my expansion, instead of writing C, I write 12 into place value 1. Second digit is 4 into place value 16. Others are 0. So if we solve this, 12 ones are 12. 16 fours are 64. Plus 0, plus 0. Nothing in front of this. So 64 plus 12 would be 76 to the base 10. So 004C to the base 16 is equal to 76 to the base 10. Take a moment to understand what is important. We converted the letter to the corresponding value number and used it in the expansion. Like A we replaced with 10, C we replaced with 12, and then did the solution. Let us try to solve some problems. Try to solve df to the base 16 and convert to corresponding decimal. Give it a try. Make sure you replace the letters with the corresponding number. F with 15 and D with 13. Let us see. So first digit is F. So F stands for 15. So first digit is 15 into place value 1. Second digit is D. D means 13. So 13 into place value 16. Others are 0. Now if you solve this, 15 ones are 15. 16 13s are, we get 208. 16 10s are 160 plus 16 3s are 48. If we add that, we get 208 plus 0 plus 0. Now if we add this, 208 plus 15, 208 plus 10 is 218 plus 5 is 223 to the base 10. So 00df to the base 16 is 223 to the base 10. Cross check. Did you get the same answer? Check with these place values. Were you able to replace the correct place values? If you had done that, you would get the correct answer. Try to solve one more problem. This time 01AE to the base 16. We want to convert to decimal. Give it a try. Let us see. So first digit is E. E corresponds to 14. So we write 14 into place value 1. Second digit is A. A corresponds to 10. So 10 into place value 16. Third digit is 1. 1 into place value 256. So 16 to the power 2 is 256 for us. Third digit is 0. So if we solve this, 14 ones are 14. 16 tens are 160. 256 ones are 256. Plus 0 plus 0. So 256 plus 160 plus 14 comes to 430 to the base 10. 01AE to the base 16 is 430 to the base 10. Take a moment to understand again. This is how we convert a given hexadecimal number to a corresponding decimal number. Let us recap what we learned today. First, we understood about valid digits in a hexadecimal number system, which is 16 minus 1. So digits go from 0 to 15. But the problem is after 9, we get 10, 11, 12, which are 2-digit numbers. But how do we write it in hexadecimal? We make use of letters A, B, C, D, E, F. A for 10, B 11, C 12, D 12, 13, E 14, F 15. We may even sometimes get small letters there. Both mean the same. These are the valid digits used for representing a hexadecimal number. Then we learned how to convert a given decimal number to hexadecimal. Take the given number and start dividing by 16. Do the classical division and you get a quotient and remainder. Note down the quotient and remainder. If you can continue to divide, do the classical division again so that you get next level of quotient and remainder. Write down the same. So do it till you reach the last digit that cannot be divided. Once we reach there, if the numbers are above 9, that is 10 to anywhere between 10 to 15, make sure you write the corresponding letter to be written. For 10, you write A, for 14, you write E, and write the answer in this order. So in this case, we write 1AE to the base 16. We also learned how to convert a hexadecimal number to decimal, where we note down powers of 16. For all places where we get these letters, we write the corresponding value while doing the expansion. Like in this case, for E, we took 14 while expanding. So 14 into place 1. And for A, we took 10. So like this, if we expand and solve this and add the numbers we get the corresponding decimal number. Till now, we have understood the number systems in detail. But now the question is, how do we use this number system in computers? How are they used? In the next session, we'll understand how these number systems get used in the computer and how binary and hexadecimal number systems are the core of how computers operate. If you like the video, please like and subscribe. Press the bell icon to know when new videos are uploaded, and also share the video among your friends and family. Thank you for watching and have a great day.